What is a set? Set is a collection of distinct elements. Okay, so consider anywhere where you have different elements that are distinct. You can think of it, all of those elements, and you can fit it into one place. Okay, then you name it. That is a set. So you are just concerned with the elements. You are just concerned with the distinct elements, and not in the order that you are collecting them. So this is what a set is. A set is a collection of distinct elements. For example, think about university. In the context of university, all students are distinct. Okay, so you can just put all of the students into one entity and call it a set of students. You want to pet a cat, and you go to a shop, and you ask the shopkeeper, what are the different breeds of cats. Now each breed is distinct, and because all of the breeds are distinct, then you put them into one entity called as breeds of cats, and in it each element is nothing but the different breed of cats. And set is very important, because building upon set theory, other concepts are derived. For example, the counting principles. Okay, in combinatorics, we will see that in combinatorics we are looking to find out the ways of doing things, in what ways, in how many ways you can achieve this operation, achieve this task. There also, each way is one distinct element. Each way is one distinct element. Let's say you have to perform two tasks, task 1 and task 2. And if you perform both the tasks, task 1 and task 2, then your objective is supposed to be fulfilled. Now, there is a set which includes the ways to perform task 1. And then there is another set which every element of it is the ways to perform task 2. And we will see in the combinatorics that the total number of ways to achieve your objective is going to be the number of elements in task A in task 1 multiplied by number of elements in task 2. Actually, this is very basic fundamental principle of counting, and this is mostly, it is very commonsensical also. But you will see that the set theory is the base for all of those. Even in computer science, in the subjects of theory of computation, entire theory of computation is a set membership problem. When I will start theory of computation, you will see that a language is a set of strings, and the whole of theory of computation almost is nothing but you are given a word, and you have to find out whether this word belongs to the language or not. What it really means is that whether this word is an element of this language, where language is a set. So in combinatorics is built upon set theory. In your theory of computation, because set is very fundamental. Set is just a collection of distinct elements. Like I've given you many examples. Everywhere where you find a distinct elements, and you are not, and their order is not your concern. That which element should be kept first, which element should be kept second, in what order. Order is not a factor. Then the collection of such distinct element is a set. So a set is a unordered collection of distinct elements. Unordered collection of distinct elements. Distinct elements. When I was working in an office, I used to work on Java, and there was a interface or parent class called as collection. There's something to do with sets. So even if you give the repeated values, when you call that class, which is basically a set, it will return the elements with unique values. Means even if you give the set values to be 1, 2, 3, 3, if you give, let's say, a is equal to 1, 2, 3, 3, 4, right? So even then, when you it will return a to b, it will always return a to b 1, 2, and 3, 1, 2, 3, and 4. So even if any element is coming more than once in set, we are only dealing with distinct elements. So duplicates are not allowed. Duplicates are just ignored. Okay. So cardinality of A. What is cardinality of a set? Cardinality of the set is number of elements in the set. So cardinality of A is cardinality is represented like this. So this means cardinality of the set, which is equal to number of elements in the set. So cardinality of A is 4. Okay, cardinality of A is 4. And what are the elements of A? 1 is an element, 1 belongs to A, 2 belongs to A, 3 belongs to A, and 4 belongs to A. So because these are 4 elements, so cardinality is 4. Okay. So let's take only 1, 2, 3, 4. Let's take 1, 2, 3. Set is an unordered collection. Unordered collection. So we are just concerned with this distinct elements. So any other set, let's say if I take another set, any set with the same elements, 1, 2, 3 only, B is 3, 2, 1, and any other set, C is 2, 1, and 3. Then all of these are equal sets mutually. A is equal to B, A is equal to C, B is equal to C, B is equal to A. So I was talking about that class in Java, which is a set. So what happens is every time that you call a set, it will return the elements, same elements, but their order may not be same. Every time the set is called, then what it returns is a set with same elements, but the order can be changed because order is irrelevant. We are not concerned with the order in which we are collecting the elements, like what element is to be collected first, or what is second element, what is third element. So instead, we don't talk like that. That what is the first element of a set, what is the second element of a set. It's just what are the elements of set. This is not an array. Array is an ordered collection of okay, later on, but array is an ordered collection of similar data types. Leave it. So all of these elements are same. A is equal to B. This is about the equality of two sets. Two sets are equal if their elements are same. If they have same elements, then both sets are equal. What is a subset of a set? What is a subset? So we are concerned with set A right now. So what is a subset of set A? If there is any other set whose elements are from set A, what does it mean? It means that a set B is said to be a subset of set A. A set B is said to be a subset of set A if all the elements of B, all the elements of B is also an element of A. Is also an element of A. So take two sets. B is equal to 2, 3, and C is equal to 3, 5. Now, out of these two sets, B is the subset of A, but C is not a subset of A. B is a subset of A, and C is not a subset. C is not a subset of A. Why? Because all the elements of B, which is 2 and 3, all of the elements of B is also in A, or the elements of B are from set A only. But elements of C are not from set A alone, because C contains 5, which is not which is not an element of A. So 5 belongs to C. This is the symbol to represent. So on this side, this is the element, okay, and this is your set. So belong symbol means that this element belongs to this set, or this is the element of this set. So 5 belongs to C, okay. But 5 does not belongs to A. So there is at least one element in C that is not from A. So C is not a subset of A. Okay. If a set is given to you and you are asked to form a subset from this set, so you know that the elements for a subset has to come from A only. Has to come from A only. And from the definition of a subset, the set A is a subset of itself. From the definition of subset, if all the elements of B, if all the elements of B is also an element of A, so definitely all the elements of A is an element of A. So every set is a subset of itself. Every set is a subset of itself. So every set is a subset of itself. Now, how do you form a subset? If a set is given to you, like A is given to me, and if I have to form a subset of A, how can I do that? So it is clear that the elements of that subset is going to come from A only. Is going to come from A only. So how can we form a subset? For every element, I have two choices. That in my subset, whether I will include this element or not. I may in my subset, I may include one or I may not include one. Okay, let's say I don't include one, but I include 2 and 3. Then this is what that subset is. So you can say that B is formed. How B is formed? Because I had two choices for every element. If I choose all of the element, then I get the set itself. And that is what it is. Every set is a subset of itself. I don't choose one. Every element has two choices. So for one, I am not choosing it to be a part of my subset. But other elements, 2 and 3, is a part of my subset. So B is a set which happens to be a subset of A. So let me write all possible subsets of A. So elements of A is 1, 2, 3. Okay. Now I know one of the subset is the set itself, and that is when we choose all of the element to be an element in my subset. If I choose every element of A to be an element of my subset, then what we get is this set 1, 2, and 3, and this is nothing but the set itself. So this is one of the subset. This is trivial subset. One of the trivial subset of a set is the set itself. That is when we choose every element to be in my subset, to be an element in my subset. Now, let me choose the elements, let me choose the subsets of cardinality 2. So the cardinality of the subset is going to be from 0 to 3. The length, the cardinality of A is 3, and my subset, the elements of my subset can be from set A only. So the maximum length of my subset will be 3. That is when the subset is the set itself. And for any other subset, what I'm going to do, either I'm going to pick 2 elements and not pick 1 element, or I'm going to pick 1 element or not pick 2 elements, or I'm going to not pick any of the element, because for every element I have 2 choice. So let me write possible subsets of cardinality 2. So for cardinality 2, for every combination, so if for every combination I am getting 1 subset. So let's say for cardinality 2, I have to select 2 elements in my set. I have to select 2 elements in my set, right? Let's say I don't select 1. If I don't select 1, and then I will select 2 and 3, and this set is 2, 3. Similarly, one another possibility is that I don't select 2. If I don't select 2, then my set, I get another subset which is 1 and 3. So as you can see, to form a subset, for every element of A, you have 2 choices. Either this element is in your subset, or this element is not in your subset. And because of this, you are getting different combination. In this combination, all 1, 2, 3 is in your subset. In this combination, 1 is not in your subset, 2 and 3 is in your subset. So in this way, how many combinations you will get? This is very much like 1, 2, 3 is very much like Boolean table with 3 Boolean variables, and every variable can take value 0 or 1. So number of combinations possible is going to be 2 power 3. So here it is number of subsets possible for this set A is going to be 2 to the power 3. This time I will choose 1 and 2, and I will not choose 3. So my subset is 1 and 2. So these are all the subsets of cardinality 2. Now I will choose all possible subsets of cardinality 1. How can we do that? So for 2 elements, I'm not going to make it a part of my subset, and for 1 element, I'm going to put it in my subset. So in how many ways can you make the cardinality 1? So every time I'm just going to select 1. So let me select 1, then 2 and 3 I'm not selecting. I'm not selecting it to be my to be an element in my subset. So this is my subset. Then I'm selecting 2. Then I'm selecting 3. Now there is one more type of set. There is, okay, I've not discussed the types of sets, but there's one type of set which is called as empty set. Empty set is, okay, how a set is represented. A set is represented by curly braces with elements, with all the elements separated by commas. So the elements of A is 1, 2, and 3. So it is enclosed between the elements of the set is enclosed between 2 curly braces, and they are separated by commas. So if a set does not have any element, then you write it like this. What does it mean? That this is a set. No doubt this is a set, but it has no element. Okay, that's what a empty set is. A set, it is a set, but no element. And it is also it is also represented as phi. So what phi is? Phi is equal to empty set. So one of the possible combination is that you don't select any of the element to be in your subset. So, and that is your phi, or this. So total number of subsets of set A is 8. There are 8 total subsets. These two, this and this, they are called trivial subsets. For every set, the set itself and the empty set, they are the trivial subsets of a set. Empty set is a subset of any set. Okay. For any given set, the set and the empty set, these two are trivial subsets of a set. Trivial subset. And remaining, so these two are trivial and remaining are subsets. One more thing, there is something called as proper subset. So what is a proper subset? Proper subset is a subset of set that is not the set itself. Or in a proper subset, you have the cardinality of proper subset has to be less than the cardinality of the set, or there is at least one element, and this is the real definition. A proper set subset of a set is when there is at least one element in the set which is not there in subset. So apart from this, for every other subset, there you can find at least one element which is in A but not in the subset. Like for this example, 1 is not a part of the subset, or 2 is not for this subset, 3 is not in this subset, 2 and 3 is not present in this subset, 1 and 3 is not present in this subset, 1 and 2 is not present in this subset, none of the element is present in this subset. So all of these subsets are proper subset. And for proper subset, how do we represent proper subset? For example, let's say this is my set B. B is equal to 2 and 3. Then how do I represent that this is a proper subset? The symbol for proper subset is this, so that B is a proper subset of A. Okay, so it is also a subset, so you can write, let's say if this is C, then you can write C is a subset of A, but C is also a subset of A. This is true also, and this is true also. Okay, but in this case, this is only a subset of A. This is only a subset of A. This 1, 2, 3, this is not a proper subset. This is not a proper subset, but this is a subset. Okay, so as you can see that for a given set of length 3, the total number of subsets possible is 8. If the size of the set is n, if the cardinality of the set is n, then what is the total number of subsets possible? It is going to be 2 to the power n, because then how many combinations are possible? 2 to the power n. Okay. So if the cardinality of A is n, the number of possible subsets of A, number of possible subsets of A is equal to 2 to the power n. What is powered set of A? What is a powered set of A? Power set is a set of all the subsets of A. All the subsets of A. So what is the power set of A? Power set of A is going to be equal to all of this. Means power set of A, in the power set, each element is a set. So set can have a set as an element. So it is possible. It means, of course, yes, it has to be distinct element. Set can have anything as its element, anything. So not numbers. Like in the introductory video, student 1 is a set. Can be one element. Student 2 can be another element in a set of the students. What is the power set of A? Power set of A is 1, 2, 3, 2, 3, 1, 3, 1 2 1 2 3 and 5. So this set is a power set of A. So if the cardinality of A is n, then what is the cardinality of power set of A? If cardinality of A is n, then what is the cardinality of the power set of A? This is equal to 2 to the power n, because there are 2 to the power n elements. There are 2 to the power n subsets of a set. So each subset is an element of power set. So the cardinality of power set is 2 to the power n. This is trivial subset. This is trivial subset. Now you can say that this is one of the representation of set. This is how one of the way to represent a set is you have a curly braces and that encompasses all the elements which are separated by commas. There's another representation of set. You can represent set using a statement of English language that is called set builder notation. So that statement itself encompasses all the elements, all the possible elements. How? For example, in this case, A is equal to 1 2 3. I can write in English statement something like A is equal to X, such that X belongs to natural number and X is less than 4. Then this is nothing but this. This n is also a set of natural numbers. N is set of natural numbers. So this is the example where number of elements is 3. But there are the sets can be finite set or it can be an infinite set. Some of the very popular infinite set, one of them is natural number, set of natural number. So which is n is set of natural numbers. Similarly, z set of all integers, q set of all rational numbers, r set of all real numbers. These are some of the popular infinite sets. Okay, what is the significance of set and subset? What is the significance of it? All of the subsets of this set A are nothing but set in themselves. They are the elements has to be decided from A. So it's like the world of A. So it is, in other way, you can understand this as that in the world of A, these are all possible sets that can be. In the world of A, this is the all possible sets that can be. For example, take the case of university. In university, you can have one set of students. Some students may be learning physics. Some students may have opt to learn chemistry. Some may have opt to learn mathematics. Some may have opt to learn about politics. Okay, so every set. So all the other sets, means a student who learn physics, they are going to be, the elements of these sets are going to be from the elements of set of students only. So set of students is like a universal set, and every other set in the context of university is a subset to this universal set. So likewise, in this case, A is a universal set. So universal set, A is a universal set, and every other set in the world of A, every other set is a subset to this A, because every other set, the elements will come from A only. Similarly, in case of university, for every other set, like physics students, set of chemistry students, set of politics students, set of English students, their elements are going to come from set of students only. Now, it might happen that, let's say, there is one subject where every student is learning that subject. For example, English literature. Everyone is learning that English language. Then In this case, this subset is the set itself. Like in this is the scenario of this, that that every set is a subset of itself. Similarly, there must be some subject where teachers just come to the classroom, but there is no one because nobody has opted to study that subject. Teachers just getting the salary, and the classroom is vacant. What can that subject be? What can that subject be? Let's say history. Let's say it's a college. College name is University of Science, but there is a history subject also, and there's also a history teacher in it. But nobody is interested in studying history. So in the set, so there is a set, that a set of history students or students of history. So there is a set, but there is no element in it. That is what is empty set is. Okay. So this is the significance of about set and subset. So what is a universal set? A universal set is a set that is a superset to every other set. So for a given context, there is one universal set. Context of city population. What is the universal set? It's the set of all people in the city, and set of men, set of women. These are the subsets. So men or women, in these subsets, the element has to come from this universal set, which is the set of all people. So this is what it is. There's another representation of set. Right? I talked about this is one representation, curly braces, and inside of the curly braces you write every other element with a means separated by commas. The other notation is set builder notation, and there's another pictorial representation which is called as Venn diagram. In the next video, we will learn about set operations. So most of the set operations or the next video maybe will be properties of sets. All of them are very self-intuitive. Self-intuitive means you look at the property and you are like, obviously it has to be like that. And even for some properties where you don't get that obvious feeling, those properties can easily be visualized using Venn diagram. So maybe not in this video. In the next video, I will first start with Venn diagram, and then I will also cover set operations. Thank you very much. Now in this video, let's look at the product of sets. So what is the product of two sets A and B? Let's say you have two sets a set A and a set B. Then what is A cross B? So we have seen different set operations like union, intersection, set difference, set symmetric difference between two sets. And the result of it is also a set. This is also one of the set operation. And the result of this set operation is also a set. Okay. A set is an unordered collection. But the result of it is also an unordered collection, but unordered collection of ordered pairs. So this is a very important point. So A cross B will give you set, no doubt set, which is an unordered collection. Unordered collection. So set of all possible ordered pairs. Set of all possible ordered pairs. Okay. So what do I mean by this ordered pairs? What is this ordered pair? Okay. Like let's say if A is 1, 2, and 3, and let's take B to be A, B, C. Then what is ordered pair? Means that this is equal to a set. This is a set which is each element of it is a pair. Each element is a pair of element. Means each element is a pair X and Y, where X belongs to A and Y belongs to B. Okay, such that X belongs to A and y belongs to b. So for every a, what are the ordered pairs possible between a and b? 1 and a, 1 and b, 1 and c. Because for every a, it will come, each element of a will come with each element of b. With the in this ordered pair, why it is called ordered pair? Because the first element of this pair has to be from set A, and the second element of this pair has to be from set B. So this pair is ordered pair, but because this is a set of ordered pairs, so okay, let me first write all of the possible ordered pairs. Okay, so all possible ordered pairs is 1 and A, 1 and B, 1 and C, 2 and A, 2 and B, 2 and C, 3 and A, 3 and B, 3 and C, right? So with A, A has to be paired with each element of B. So you have this. Similarly, 2 is also an element of A, and each element of A has to be paired with every element of B. So 2 will be paired with A, 2 will be paired with B, and 2 will be paired with C. That's what this is. And similarly, 3 will be paired with A, B, and C, and that's what this is. Okay. So a set A cross B set will be equal to all of these elements. And because it's a set, the order is not important. So each element is an ordered pair, but there is no order of the, it means each element is an ordered pair, but you can't say what is the first ordered pair, what is the second ordered pair. You know what I'm saying. So so it can be 3a, 1a, in any order you can write it. So it's a set, but each element is an ordered pair where first element belongs to A, second element belongs to B. Now you may be thinking that what is the use of it? What is the use of this product of sets? One of the uses in the combinatorics, actually, the multiplication rule that we will see very soon. The multiplication rule, the ways of doing things if you want to accomplish a task, and basically there's task T that you want to accomplish, but accomplishing task T means that doing T1 and T2. And let's say there are m ways of doing T1 and there are n ways of doing T2. Then how many ways you can do the task T? Okay. Should I explain multiplication rule right here? See, if let's say you have to accomplish a task T, and to complete task T means doing task 1 and task 2 both, and task 1, for doing task 1, you can do it in m ways. Okay, let's say x1 is one of the way you can do, x2 is another way you can do, and so on so on. There are m ways to perform task 1, and there are n ways to perform task 2. Okay, n ways to perform task 2. Then if you, let's say, if you take any ordered pair means that first element of this ordered pair has to be from T1, and second element from the ordered pair has to be from T2. Then any ordered pair is one way of doing T. Any ordered pair is one way of doing T, right? So if you take x1 y1, I don't know if it is visible or not. So x1 y1 is one way of doing it. X1 y2 is another way of doing it. Another way of doing it. Okay. So in multiplication rule says that if the number of elements in T1 is m and number of elements in T2 is n, then number of ways of doing T is m into n. This is a multiplication rule, because how many ordered pairs you will get is actually m into n. So number of ways of doing t is number of ordered pairs. Okay, and I am taking the ways, t1 to be a set. Okay, this is the fundamental of multiplication. T1, you can think of T1 as a set where each element is distinct way of performing T1, and T2 as a set means task T2. You can think of it as a set where each element is a distinct way to perform T2, and number of ways to perform T is the ordered pair between T1 and T2, ordered pair of T1 cross T2. Okay, number of ordered pairs of T1 cross T2. Okay, I will cover multiplication rule again separately. Just showing that how where it is applied. Actually, this is a fundamental rule of counting. There are two fundamental rule of counting: the sum principle and multiplication principle. Here, the constant is that for t to accomplish, both has to be performed in a sequence. Okay, in a sequence. First T1 has to be performed and then T2 has to be performed. The sequence can change, let's say there is another task T dash. For T dash, T2 has to be performed first and T1 has to be performed first. The number of ways would not change to perform. Then the number of ways for T to complete T1, T dash or T is same. That is m into n because multiplication is commutative. But the ordered pairs will not be same. Ordered pairs will not be same. Okay, in to accomplish. So tell me, what are the ways to do T dash? The ways to do T dash would be now y1 x1, this is one way, y1 x2, this is another way, in this manner. Anyways, multiplication rule is not to be covered here. That's a separate topic of in combinatorics. Similarly, there is a sum rule. In sum rule, we will see how the union operation of set comes into play. Okay, so set is that's why in the very first introduction to a set, I told you that the sets are very important because building upon set theory, other concepts are derived, and set is very fundamental. Just think about what is a set. It's just a collection. So collection is a very fundamental thing. Anything anywhere there is a collection, you can think in terms of set perspective. TOC is completely uh, like set membership. TOC can be summed up as a set membership problem. Anyways, so this is your A cross B. What about if there are three sets? What is the product? We are talking about product of sets. This is a product of two set is set of all possible ordered pairs. But what if you have three sets? What if you have A cross B cross C? A cross B cross C. Then this is a set of all possible ordered pairs. No, it is not pairs anymore. Means it's a set of an ordered entity, but that entity is a ordered tuple, three tuple. Actually, the ordered pairs means these ordered pairs are two tuple. You can think what is a tuple now? Right now, I will also relate it with relational uh, database. So in database, there are different types of database, but relational database is when you are storing your data as a relation, which is actually a table, and each row is called as a tuple. But each row can be thought of means it is based relational database is based upon the concept of relation only, and each tuple is actually a k tuple. For example, okay, before I explain, let me just write is a set of all possible three tuple, and I will explain what is a tuple. Okay, so let's see a case of a relational database or relation. if you are very new to the computer science and database is something that you have never heard of, then also you can understand it. Database is a uh, record keeping of entities, like, let's say, look at it. Let's say there is a university, and university is keeping a record of students. Okay, keeping a record of students. Then every student must have some student ID. It's like a register. Student ID, student name. Okay, subjects. Okay, so student ID, let's say first student is Gulam. Okay, and he studies subjects. The subject that he studies is computer science and engineering. And second student name is Moinuddin. Okay, and he studies, let's say, machine learning. Okay, machine learning comes under computer science. Artificial intelligence also comes under computer science. Okay, he is a master of physics. And there is a third student. Let's say his name is Ramesh, and he is a master of mathematics. Oh, sorry, he is a student of mathematics. Okay, and grade is that they are all are toppers, always A plus, A plus, A plus. Okay, so in this case, every row, each row is information about one entity, which entity is a student. So one row contains all the information about Gulam, all the information about this student. Second row consists of all the information about Moinuddin. Third row consists of all the information about Ramesh. And each row is called as tuple. Each row is called as tuple because it's an ordered quantity. Means the first element of this tuple is a number that indicates student ID. But if you just take out the tuple out, if you just take the tuple out, then first element has to be a number. Second element is a string, which is a name of the student. Third element is a string, which is a student subject. Fourth element is a okay, हटा दो, प्लस हटा दो, यही लिख दो, आउटस्टैंडिंग कर दो इसको, ओ ग्रेड. Fourth element of this tuple is a grade. So this is a four tuple. This is a four tuple. Something like this: 1, 2, 3, 4. Then you say it's a four tuple. If the order is important in this collection, then it's a tuple. So A cross B is set of all possible two tuples. Okay, set of all possible two tuples. Where so two tuples means ordered pair. The first element belongs always has to be from A. Second element always has to be from B. Similarly, in this case, A cross B cross C, this is a set of all possible three tuple. Three tuple means you had three elements in a tuple where the first element always has to belong to A, second element always belongs to B, and third element has to belong to C. And all such tuples possible is in your product of sets you have all such three tuples. Okay, in database, when I will start, I will again explain this. So you can think in database also, each of this is called attribute. Okay, that student ID is one attribute of the student. So this is your student table. Then each of these is one attribute, is the attribute of a student. So you can think of every attribute as a set. Then there is something called as domain, that this set will have a domain. Okay, the content of your table is going to be a subset of cross product of each of this set. Means all of these elements are tuples, and they are a subset of cross product of these sets. A set student id set cross student name set, cross product with subjects, cross product with grade. Okay, let's complete this set of product of three sets. So this is equal to nothing but x, y, and z, such that x belongs to A, y belongs to B, and z belongs to C. Okay, so let me take one example to explain. Let's take A to be 1 and 2, A and B, and let's take C to be P and Q. Okay, you will see that the number of elements in A cross B cross C is going to be 8. Actually, the number of elements, the cardinality of A cross B cross C is equal to cardinality of A into cardinality of B into cardinality of C. Every element of A, all possible pair. So for A will be connected with, one will be connected with A, then A with P and A with Q. So one A and P is one 3 tuple, and then one A and Q is another 3 tuple. Similarly, one will be connected with B, and B will be connected with P and Q. Another two 3 tuples are 1 B and P, 1 B and Q. Likewise for 2. Okay, so 2 A and P, 2 A and Q, 2 B and P, 2 B and Q. Okay, so as you can count the number of elements 1 2 3 4 5 6 7 8. So this is equal to number of elements in A is 2 into 2 into 2, which is equal to 8. So in general, so I have taken two cases, product of two sets, and I have shown that product of two sets is a set of all possible ordered pairs, which is a set of all possible two tuples. Product of three sets is set of all possible three tuples. Similarly, you can, let's say there are k sets. Then product of k sets is what? Set of all possible k tuples. Okay. And what is the number of elements in the product of k sets? It is equal to the cardinality of each set product of the cardinality of each sets. So when we have product of sets, the cardinality of the product of set is equal to just product of their individual cardinalities. I don't have to. I don't think it needs a proof. It's a straight. But let me show it. Let's take only. Let's take first two sets, and it will be easy for me to explain. Let's take two sets A and B. What is happening is that if this is your set A and this is your set B, then every element of set A is connected with every element of set B, right? So if let's say set B has m elements, n elements, let's say set B has n elements, then A has m elements. Then for every element of A in the ordered pair, in the set of all ordered pairs, each element is each element of A is adding n elements. Okay, each element of A is adding n elements. So this is your first element, let's say A1. So A1 is adding n elements to the set of ordered pairs. M elements, sorry. Similarly, A2 will add, because then now A2 will be connected with each element of B. So A2 will also add n elements, and so on. All the m elements are going to add n elements. So what is the ordered pair? It is n plus so on m times, which is equal to n into m. Okay, which is equal to m into n. Now, if there are three sets, if there are three sets, let's say there is another set A, B, and C, and C has, let's say, P elements. Now, your three tuple, your three tuple is going to be something like this, where these two, this is the, this place is for element of A, this is place is for element of B, and this place is for element of C. Now you know that you already know that set of all possible ordered pairs means this part is going to be m into n. Let me just replace it with m into n. What I mean is that this is my A cross B. Okay, so of course this is going to be, let's say, one ordered pair A1 A2 and A1 A1 B1 A2 B1 A2 B2. Okay, don't take it as a set. Why I'm doing so? Because then it will, I will explain in a while that why I'm not doing it. I am just saying that your triplet is going to be like this: A1 B1 and something from set C, A2 B2 and something from set C, A3 B3 and something from set C, and so on, so on. How many such is possible? Means I am not filling this part. I am just looking for distinct these. So how many such? There are m into n such, right? Now to include this, we have to pick it from here, and for each of this, you have p choices. You have p choices. So it becomes, in a similar manner. It becomes what? For first one you have p choice. For second one you have p choice, and so on, so on. For m into nth one you have p choice. So the number of elements become what? P plus so on, so on, p, which is equal to m into n into p. Okay, what about the product of four sets? Similarly, for product of four sets, what you will do? So for four sets, this is like principle of mathematical induction. If you were studious in your 11th and 12th, you would have understood this already, that we can apply mathematical induction to get the result. But I don't think that you were studious, just like me. So if it was four sets, then you know that there's going to be four tuple. There's going to be four tuple. Okay, so you know about, if you just take uh, if you just consider this region up to this, all the distinct elements in up to first three only, then you know that how many are those? M into n into p. And then for each such m into n into p, you have, let's say, for if you have a into b into c into d, if you have four sets, and let's say d has cardinality d, then for each such you have d choices, and then this is then the cardinality of a cross b cross c cross d is nothing but m into n into p into d. Okay, so it's okay. Now let me just directly write. I have proven. So let's say if you have set a1, set a2, set a3, so on, set ak. Okay, then this is the product of such sets. What is the cardinality of this? This is equal to cardinality of a1 into cardinality of a2 into cardinality of a3 into cardinality of a4 into so on, cardinality of ak. This is the result. Okay, so product of sets is over. Let's get little bit about Cartesian product of sets. Actually, when you have only two sets, the product of two sets is also called as Cartesian product of sets. Why? Because think of Cartesian plane. Okay, let me explain. Cartesian product of sets. Cartesian product of A and B. It is just the product of two sets is also called Cartesian product because you can represent the product of two sets in a Cartesian plane like this. Let's say this is one Cartesian plane. Okay, and this axis is your A and this axis is your B. Means this axis will have elements of A and this axis will have elements of B. Okay, let me take just A to be 1, 3, 5 and B to be 2, 4, 9. Then what is A cross B? How many elements will be there in A cross B? 3 into 3, 9 elements. So the number of elements in A cross B is equal to 1 and 3, sorry, 1 and 2, 1 and 4, 1 and 9, 3 and 2, 3 and 4, 3 and 9, 5 and 2, 5 and 4, 5 and 9. So this is 1, this is 3 and this is 5. And what are the elements in B? Elements in B is 2, let's say this is 4 and let's say this is 9. Okay, then you just plot it. So with 1, because we are talking okay, this is Cartesian product, so it is all possible pairs. So 1 and 2 will be everyone will have a point. So everywhere you will have a point everywhere. Similarly for 3, so this is something, the Cartesian product will be something like this only, because it is all possible pairs. Okay, in the next video we will read about relation. Relation is a subset of Cartesian product of sets. I will explain what relation is, but it's a subset. So subset means that some of the elements might be missing. Okay, even the Cartesian product of sets is also a relation. The product of set, Cartesian product of set is also a relation, because every set, one of the subset of any set is a set itself. So this is also one of the relation. A cross B is also one of the relation. But relation is actually can be the proper subset also. So some of the, let's say that if you miss this point or this point, this is one of the relation. So this is the difference between Cartesian product of sets and relation is that in product of set the dot will be or every possible dot, and in relation some of the dots will be missing. Some of the dots may miss. In the next video we'll talk about relation. Thank you very much. In this video I'll start relation. So what is the relation between two sets A and B? So let's say there is a relation R between set A to B. Okay. So any relation between two sets is a set of ordered pairs. Okay. Any relation R between two sets, say A and B, are set of ordered pairs formed from set of ordered pairs formed from elements of A and elements of B and elements of B. Like for example, let's say just I am taking just one arbitrary set A that has the elements 1, 2 and 3. Okay, and there is another set B that has the elements as ABC, ABC, and I am just taking one set which will a set of some ordered pairs where the first element belongs to A and the second element belongs to B. Let's say 1A and 1C, 2C, 3B. Let's say I have taken this set. Then this set is what? This set is said to be a relation. We know that A cross B is the set of all possible ordered pairs between A and B. So any relation is a subset of the cross product of set. Any relation is a subset of cross product of sets. Cross product of A cross B. So any relation between A to B, this is how we represent a relation, that R is a relation from A to B. So if R is a relation from A to B, then it is a subset of A cross B. Because if it's a relation, then the elements in the relation is going to be an ordered pairs. And A cross B, the elements are all possible ordered pairs. So anyways, you can think of, the analogy in the world of ordered pairs, set of all possible ordered pairs is A cross B. So you can think of A cross B as a universal set. In this context means in the context of ordered pairs, A cross B is a universal set. What is a universal set? The set that has all the elements in a given context. So in this context of ordered pairs, what is the universal set? A cross B. So universal set is A cross B. Okay, so any other set whose elements are the ordered pairs only, they are called relation. So any relation, the elements of a relation will come from the A cross B only. That's why any relation from A to B is a subset of A cross B. So the definition of relation that I have written here is a relation R between two sets are set of ordered pairs formed from elements of A and elements of B, right? Set of ordered pairs. So A cross B itself is one relation only, because A cross B is also a set of ordered pairs. It just happens that it has set of all possible ordered pairs, but ultimately because it's a set of ordered pairs, so even the cross product is also a relation. Okay, A cross B is also a relation. A cross B is also a relation. How do we take these ordered pairs in a relation? Means if 1 comma a is if 1 comma a belongs to R1, okay, what does it mean? It means that 1 is R related with A. 1 is R related with A. So a relation from A to B means that how the elements of A is related with the elements of B. So in this relation R1, 1A, 1C, 2C, 3B, how set A, how the elements of set A are related with elements of set B. So 1 is related with A. Okay, 1 is related with C. 2 is related with C. 3 is related with B. Okay. You can also think of the relation R as some sort of a rule. How you will relate A and B, are going to relate it by rule R1. Okay. So by this rule R1, what are the elements that are related? 1 is related to A. 1 is R1 related to A. Okay. 1 is R1 related with C. So by R1 rule, 1 is not related to B. So 1 comma B does not belongs to R1, or 1 is not R1 related with B. Okay. How do you represent a relation? This is one way to represent a relation, that you write all those ordered pairs, uh, all those valid ordered pairs, or you can represent it in this manner. This is the diagrammatic representation. Okay. The another way to represent is using a matrix also. We can represent a relation. Now, if 1 is related with A, if 1 is R1 related with A, then I write 1. And if it is not related, then I write 0. So 1 is related with A, then 1. If it's not related, then 0. 1 is related with C, yes, so it's 1. 2 is related with C. 3 is related with B. Okay. So this is about relation. Thank you. So in the last video we have seen what a relation is. That a relation is basically if a relation from set A to B is a set of ordered pairs. So if R is a relation from A to B, then R is a set that has ordered pairs as its elements. Okay, where the first element belongs to A and B belongs to B. So if it's a set of ordered pairs, we have seen in the last video that this makes any relation a subset of cross product. So any relation R is a subset of cross product of A cross B. Okay, from this we can find out the total number of relations possible between two sets. Like if say that the number of elements in A is equal to M and the cardinality of B is equal to N, okay, then what is the number of element in A cross B? The number of element in A cross B is equal to M into N, right? If a relation is a subset of A cross B, it means that number of relations possible from A to B is equal to the number of elements in the power set of A cross B and number of or the number of subsets of A cross B, right? And what is the cardinality of A cross B? It is M into N. So if a set has n elements, then what is the number of subsets? 2 power n. So the number of relations from A to B is equal to number of subsets of A cross B, and this is equal to 2 to the power. This is equal to 2 to the power the number of elements in A cross B. Okay, which is in this case it is equal to 2 to the power m into n. This is the number of relations between that is possible between two sets A and B. Let's say I have two sets, set of numbers only. Let's say set A 1, 3, 5, 7, 9, and B is equal to 2, 4, 6, 8. Okay, how many elements is going to be in A cross B then? Number of elements in A cross B will be equal to number of elements in A into number of elements in B, which is equal to 5 into 4, that is 20. So number of elements in A cross B is equal to 20. So between these two sets A and B, what is the total number of relations that you can make? So A, this is your A, okay, 1, 3, 5, 7, 9, and B is another set which is 2, 4, 6, and 8. So this is the number of elements in A cross B, which is 5 into 4, that is 20. Total number of relations possible from A to B. Total number of relations possible from A to B. You know that this is going to be equal to 2 to the power 20. 2 to the power 20. These many relations are so possible. These many relations are possible between these two sets. Let me take some rule R, okay, by which I will relate the elements of A with elements of B, which is less than or equal to. Means that the element of A is going to be R related with uh, B if A is less or equal to B. If this is your relation R, your relation R is basically R relation is basically less than equal to. Okay. So A set A and set B are related by a rule less than equal to. Less than equal to. Then what are the valid ordered pairs in this case? 1 is less than 2, 4, 6, 8. Okay. 1 will be related to 2 because 1 is less than 2. 1 is less than 4, less than 6, less than 8. Okay. 3 will not be related to 2 because 3 is greater than 2. 3 is not less than equal to 2. 3 will be related with 4, 3 will be related with 6, 3 will be related with 8. Similarly, 5 is not less than equal to 2, so they are not related by R. So 5 is not related by 2 with 2. 5 is not less than equal to 4, so 5 is not R related with 4. 5 is R related with 6, 5 is R related with 8. Okay, 5 is R related with 6, 5 is R related with 8. 7 is not related with 2 because 7 is not less than equal to 2. So 7 is not related with R related with 2. 7 is not R related with 4. 7 is not R related with 6. But 7 is R related with 8. So 7 will be related with 8. But this 9 is not related. The element 9 is not paired, cannot be paired with any element from set B. So 9 is not related with any element of set B. Okay. So my relation R will be 1 and 2, 1 and 4, 1 and 6, 1 and 8, 3 and 4, 3 and 6, 3 and 8, 5 and 6, 5 and 6, 5 and 8. 5 and 6, 5 and 8, 7 and 8. Okay, this is my relation R. This is my relation R. Okay. Now, if you just interchange the positions in each ordered pair, the second element becomes the first, and first element becomes the second. Okay, then it's a relation from B to A. Okay, what I am saying is this: I am naming any other relation R1. Okay, R1, and this R1 is in place of 1 and 2. The ordered pair is 2 and 1. Okay, I will just interchange the position in each ordered pair in my R1. 4 and 1, 6 and 1, 8 and 1, 4 and 3, 6 and 3, 8 and 3, 6 and 5, 8 and 5, and 8 and 7. Okay. Now this R1 relation is like this is your R relation. The first in R relation is a set of ordered pairs where the first element is from set A, second element is from set B. So we say that R is from A to B. Relation R is from A to B. Here the first element is from set B and the second element is from set A. So R1 is from B to A. Relation R1 is from B to A. Means how the elements of B are related with A. So A to B means that a relation from A to B means that how the elements of A are related with B. Relation from B to A means how the elements of B are related with A. Okay. Also this R1 is the inverse of relation R. Okay. This R1 is also inverse of relation. So let's talk about inverse. Inverse of a relation. This R1 is the inverse of R. That is, I can say that for any relation, if R is a relation from A to B, if R is a relation from A to B, then R inverse is a relation from B to A, such that how R inverse is obtained is you are just interchanging the positions, interchanging the elements in the ordered pairs of R. So this R in R1, you have achieved this R1 or you have got this R1 by interchanging the positions. Okay. Also, you can understand what is the relationship rule would be then from B to A. R is less than equal to R is less than equal to, then R inverse is greater than or equal to. Okay. From R is greater than equal to, then only the elements are interchanged. So here 1 is related with 2, here 2 is related with 1. Okay. It's just that the elements are interchanged. Okay. So 2 1 4 1 6 1 8 1, and then 4 and 3 are related because 4 is greater than 3. 4 3 6 3. Okay, 6 3 and 6 5 will also be related because 6 is greater than or equal to 5, and then 8 is greater than all of it, right? So 8 will be related with 3, 8 will be related with 5, 8 will be related with 7. Okay, and here the 9 is not related, 9 is not related. because none of the elements here can be greater than or equal to 9. So this is your concept of inverse of a relation. Inverse of a relation means that A belongs to capital A and B belongs to capital B, and if A is related with B, if A is R related with B, then in R inverse, B is R inverse related with A. Okay. The inverse of a relation R. Inverse of a relation R. R inverse is equal to B comma A such that A comma B belongs to R. Okay. So you can also think that what is the inverse of A cross B? Because A cross B is also a relation, right? So the inverse of A cross B is B cross A. Inverse of relation A cross B is B cross A. A cross B is a universal set in the context of ordered pairs from A to B. This is A cross B. Any relation R is going to be inside of this universal set A cross B. Okay, any relation is a subset of A cross B. So any relation R is going to be completely enclosed by this rectangle. There is a concept of complement of set. Similarly, what is will be the if this is relation R, this is the relation R. Okay, this is a relation R. R is a set. So what is the complement of R? The complement of R is R complement is equal to A cross B minus R. A cross B minus R. So A cross B has set of all possible ordered pairs. Any relation has a subset of those ordered pairs. So R complement, the complement of the relation, it includes all of this. So whatever ordered pairs lies outside of this set, whatever ordered pairs that are not in this set, all those will come under R complement. So R complement is equal to R complement is equal to A cross B only. Okay, where A belongs to capital A, B belongs to capital B, such that A belongs to capital A and B belongs to capital B. Okay, and A comma B does not belongs to R. This is your R complement. This is your R complement. Or R complement is equal to A cross B minus R. In one of the video that is titled as set operations involving universal set and null set, you can correlate here this expression from there also, that the complement of the set is equal to uh, universal set minus that set. Okay, this also goes to show that the relation R union R complement will give you what? Will give you A cross B. Okay. Now in the next video, I will start relations of the same set A, which is to say that relations from set A to A. What does it mean that if I say that relation of from A to A, what does it mean? It means that how the elements of a set are related to each other, or how one element of a set is related to some other element in the set. This type of relation is, we call it as relation on set A. Relation on set A. Okay. Thank you very much.